Good morning, everybody. How are you today? I think you all are well. And today is my first class for class 10. And my name is Dinesh Chandra Thakur. I will teach you this year OPT math. And first of all, we know about the contents of the OPT math of class 10. Then only we discuss about the certain topics. Now here we have the name of the topics: algebra, which is also in class 9, limit and continuity, there is adding continuity, matrix, coordinate geometry, trigonometry, vector, transformation, statics. Here we have 8 chapters in class 10, and some chapters also there is subtopics. And in first there is algebra, and from algebra in final examination in SE there is asked 21 marks questions. From limit and continuity 5 marks. From matrix 9. Coordinate geometry 15. Trigonometry 20, only 20 marks asked from trigonometry. From vector 10, also transformation and statics contain 10. And when we total resolve, we get 100 marks. This conclude that from OPT math full mark 100. Full mark 100. There is not pass mark in SE. Now first we discuss about algebra. First we discuss about algebra, and in this chapter, in these topics, there is many subtopics. Now I am going to write the name of subtopics. In first there is function, second polynomial, third sequence and series, in fourth there is linear programming problem and quadratic equation. And in only we read in algebra about these topics: function, polynomial, sequence series, and linear programming problem. And also there is in this chapter there is also include quadratic equation. All of you know how many subtopics in the algebra. In first there is function, second polynomial, third sequence series, in fourth there is linear programming problem and quadratic equation. Okay, I give you 2-minute times. Now write down. Okay. Now in algebra, in first there is function. So first we discuss about function, and we know about the definition of function. In class 10 there is a start from the inverse function, there is composite function. To know about the inverse function and composite function, first we know about what is function, then only we can find its inverse, its composites. Yes, so I am going to first clear about the concept of the function. Now here let us consider some relations in mapping diagram. Now here P Q 1 2 3 1 4 9 let it be function f. Other it is relation f a b c p q it will be g m n minus 1 0 1 1 0 4 h a b c x y z. Now I am here draw height mapping diagram and I am going to describe each mapping diagram. Now listen careful. Here in this mapping diagram each elements of first set map with unique elements of second set. Now listen here, each and every elements of first set map with unique means single with single elements of second sets, then only it is function, otherwise it is not function. So here this follow the rule. What is the rule? Each and every elements of first set map with unique elements of second set. Mind it, this is main condition to be function. Here each and every element of first set map with unique. What is the meaning of unique? Single with the unique elements of second set. So it is function. It is function. Again look in second mapping diagram. Here also A map with single element, A map with unique element, B map with single elements, that is unique elements, C map with unique elements, there is no left anyone. So this also, this diagram, this mapping diagram also follow the condition. Each and every elements of first set map with unique elements of second set. So it is also function. You write here, it is function. It is function. Now go in third mapping diagram. Here in this mapping diagram each elements of first set map with unique element of second set, map with unique elements of second set, that is map with the single elements of second set. Here minus 1 map with 1, 1 map with 1, 0 map with 0. So these all elements of first set have map with, associated with, link with the single elements of second set. So it is also function. It is function. Here in this mapping diagram each elements of first set map with the unique elements of second set. No, here elements, first of all there is one elements left, there is not each elements map with second set, the elements of second set. So first there is not follow the criteria, so it is not function, because one element, if there is one element left in first set, then it is not function, it is relation. There is written, these all are the relation, but it is not function, because there is not each elements of first set map with unique elements of second set. And also there is one fault here. There is two image, there is not unique. A map with two elements. If if any elements of first set map with two or more than two elements, then it is not unique, so it is not function. It is not function. It is not a function. And in this mapping diagram, now look here. Here also, in this mapping diagram, one element is left, but your condition is what is? What should we follow the mapping diagram to be function? If there is each and every element of first set map with second set, but there is one element left. There is not each and every element of first set map with elements of second set, unique elements of second set, so it is not function. It is also not function. It is not a function. Okay, all of you write down. I will give you 1 minute time to write. Okay. Okay. Now I am going to write the definition of function. I am going to write the definition of function with the help of the flowing diagrams. Now here how we write the definition? The first we look here in which condition there is relation is function. So by the help of the condition we can easily write the definition. First we take two sets A and B or P and Q. These two are non-empty sets. Now write there. Let A and B be two non-empty sets, then the relation from set A to set B is said to be function if each and every elements, here A and B be two non-empty sets, here A and B be two non-empty sets, then the relation from set A to set B is said to be function if each and every elements of set A mapped with unique element of set. All of you know, I already described in which condition the relation is function, and if there is not follow the condition, then it is not function. By the same condition we write here definition. Let A and B be two non-empty sets, then the relation from set A to B is said to be function if each and every elements of set A map with unique elements of set B, then only it is function. It is denoted by f A to B. We can denote the function from A to B in this way. Okay. Now I am waiting. You write the definition. No. And before start inverse function, composite function, we discuss about the types of the function. Types of function. Types of function. Now here 1-to-1 function, onto function, into function. Here there is mainly three types of functions: 1-to-1 function, onto function, into function. So first, to know the definition of 1-to-1 function, onto function, into function, we know about the range and domain. Now look here. Here we have P, Q, 1, 2, 3, 1, 4, 9, 16. First, one map with one. Here, let us consider a function f. Let us consider a function f p to q. First, let us consider a function p to q. First, we know about what is the range, what is the domain, codomain, and image of the function. Then only we can know about the 1-to-1, onto, into function. So here, first we discuss about domain. Domain, the set of all the elements of first, the set of elements which belongs to in first set, or the set of all the elements of first set is called domain. Here in this function, what is the domain set? Here domain set is 1, 2, 3, 1, 2, 3, and the range, the elements of second set, of the function which have their preimage. The elements of second sets which have their preimage only you write in the range 1, 4, 9. Here 6, here 16 has, there is not, 16 have no preimage, so it is not written in the range set. Only you write such types of elements which have their preimage, otherwise it is not listed in the range set. Then we have codomain set. Codomain, the codomain, the set of all the elements of second set, the set of all the elements of the second set, that is in set Q, the elements which belongs in set Q, these are all are the set of codomain 1, 4, 9, 16, and these are the idea to find domain, range, and codomain of the function. And also image of 1 is, what is the image of 1? 1. Image of 9 is what? What is the preimage of 9? The preimage, the set of element of first set represent